First one, the metallography phase of practice. Well, we can see here the 100 zoom on the material on our mountain steel 1018, and then we can see the 500, and then we can see the 1000. The grains of the material they are not so clearly to see, but they're able to determine how many grains per inch square we can see on the material. In the tensile test, we can see now how the steel 1018 breaks after 22% of elongation, and in the ductile form we see an area of reduction of 64 percentage, and the loads that in our graph we can represent for the yield strength and the tensile strength, and therefore we can calculate the stress, and we can see it right here. Here we can see the Brinell test, the Rockwell test, and the Vickers test manually as automatic by tables. All this to prove the hardness of the material is a characteristic of a material, and we need to determine by tables and by calculations the diameter of the indentation, and be able to determine to a normal of HB, or in this case UTS, the hardness of the material. Was It is the most practical testings, but also the most efficiency to prove a materials and with very low deformations of it. For the impact test, we can see how the material was forced to a 27 pounds feet force before it breaks into a ductile material, because here in the photo we can see how the element strengths its plastic deformation and not a brittle deformation. We were at same room temperature, and all the calculus were made exactly perfectly, and the pendulum was working correctly. The machine I liked the most was the Brinell, because with a very little indentation, but with a lot of air compressed, you can deform the material and be able to determine the hardness of the material. It's very easy. For me, obviously, the equipment that is mostly used is the universal machine, because we need to test the tensile strength of any material, and you can make several tubes several times the same experiment to determine the properties of the material. And most of the time all our materials are to be tested as tensile, because we strengthen the material so long, and we want to determine how much force and pressure it can absorb before deforming, and if it is ductile or brittle. But in most cases all the universal testing make the materials ductile. What I must learn about all this laboratory practice was to use all these equipments correctly and avoid any damage in the material. This equipment allows you to determine some characteristic of our materials, so we can build better composites and be able to know more our materials in case of making a project on instead in some years, knowing the capacity of the material that we are using, and if this is the correct material we want by its characteristics. The thing that I most like about the laboratory was the same also as the I learned, is to use all the equipment, all the procedures, and be able in our final test to use more equipment that we generally use. And the last thing I like about laboratory was it was too early on Wednesdays, and only 1 hour. If it would be more, it will be good.